combination question. That's a wonderful type of question, one of my favorite styles of questions. Here we are saying, does statement 1 imply statement 2? Does statement 2 imply statement 1? That's what we need to evaluate. 1 implies 2, but 2 does not imply 1. 2 implies 1, but 1 does not imply 2. All of those type of questions are our answer choices. And so 1 implies 2. What does that mean? Statement 1 implies statement 2. What does it mean? That means if statement 1 were true, then we can definitely say that statement 2 will also be true. And if statement 1 is true, we can be sure that statement 2 is true. The other way around, if statement 2 is true, we can be sure that statement 1 will be true. If first thing you can say for sure, if you take the first one for granted, you can say that the second one has to be true. The logical way of constructing this, if 3m plus 5n were even, then can we say m plus n is even. The other thing that we are verifying, if m plus n were even, can we say for sure that 3m plus 5n is even. That's what we are evaluating here. Let's go to this. Let's have a go at this. 3m plus 5n is even. Does this imply this? Sum of two numbers is even. 3m and 5n. The sum is even. When can this happen? When both are even or both are odd. Sum of two numbers is even. When can that happen? When both of them are even or both of them are odd. If you have one even number and one odd number, the sum will become odd. The sum is even, either both are even or both are odd. That much we know. So if 3m is even, this means 3 into m is even. That means m is even. If 3m were odd, then this means m is odd. 3 times m is even, that means m should be even. If 3 times m is odd, that means m should be odd. Or the same rule works for 5n also. If 5 times n is even, then n has to be even. If 5 times n is odd, that means n has to be odd. So if 3m and 5n should be both even or both odd, this tells us that m comma n should be both even or both odd. Because if 3m is even, then m has to be even. If 3m is odd, then m has to be odd. If 5n is even, then n has to be even. If 5n were odd, then n has to be odd. So if 3m and 5n either both should be even or both should be odd, then m and n should be both even or both odd. So what can you talk about m plus n? M plus n would be either odd plus odd or even plus even. In both cases, this is even, or statement 1 implies statement 2. If 3m plus 5n were even, you can say for sure that m plus n is even. Wonderful. Let's look at this the other way around. M plus n is even. What can you say about 3m plus 5n? This is simpler. M plus n is even. That means we should have either both odd or both even. This we know. We've already done. We've already understood this idea. If sum of two natural numbers is even, then both should be even or both should be odd. So m comma n both odd. What can you say about 3m and 5n? If m were odd, 3m would be odd. If n were odd, 5n would be odd. So if these are both odd, these are also both odd. If m comma n are both even, then 3m and 5n would also be both even. Or if m plus n is even, then either both are odd or both are even. And in 3m plus 5n, again either both are odd or both are even. So 3m plus 5n would be either odd plus odd or it will be even plus even. In both cases, the sum would be even. Or statement 2 implies statement 1. 1 implies 2, 2 implies 1. We're looking at answer choice C, C for chocolate.